All right, if you're a data scientist, you definitely know this feeling. You've spent weeks, maybe even months, locked in a Jupyter Notebook, right? You've built this incredible machine learning model. It's working perfectly on your machine. But then comes the hard part, doesn't it? How do you get that brilliant piece of work out of the notebook and turn it into something, well, real? Something your team can actually use, something that runs reliably every single time. That's exactly the challenge we're going to tackle today.
And honestly, this is the million-dollar question in MLOps, isn't it? Your model could be a total masterpiece, but if your teammates can't run it, or if you try to deploy it to a server and everything just breaks, what's the point? All that value is just trapped on your laptop. You know, this right here is one of the biggest hurdles for data scientists looking to step into a more production-focused AI engineering role.
Okay, so let's build that bridge from your notebook to production. In this explainer, we're going to dive deep into the one essential practice that can turn that prototype of yours into a professional, robust system. And that is learning how to properly package your Python code.
So, what's our solution? It's the humble Python package. Seriously, that's it. At its core, a package is just a standardized way to organize all your code and all its files into one single structured unit. The best way to think about it is like a neat, perfectly labeled box. Inside that box is everything your project needs to work anywhere, anytime.
And I want to be super clear about this. This is not just some boring software engineering chore we're adding to your to-do list. No way. In the world of MLOps, packaging is the absolute foundation. It's the bedrock. It's what allows us to build machine learning systems that are actually reproducible, easy to maintain, and, simple for a whole team to work on together without stepping on each other's toes.
Okay, but let's get specific, right? What are the actual benefits you get when you take the time to package your project? Well, it turns out there are a bunch, and they solve some of the biggest, most common headaches that we all face in this field.
So yeah, packaging really does solve the biggest headaches. First up, reproducibility. This is the big one. It finally ends that, well, it works on my machine problem by bundling your code with its exact dependencies. Next, you get modularity. This forces you to organize your code into reusable components, which is a lifesaver down the road. Then there's simplified deployment. Instead of sending a zip file of scrapes, you're just sharing a clean version library. And finally, a clear structure. This enforces a standard layout, making it way easier for your entire team to jump in and collaborate effectively right from day one.
Okay, so let's say you're sold on packaging. The next question is obvious. What tools do I actually use? And this is where so many of us get stuck, because let's be honest, the Python ecosystem can feel a little bit like the Wild West, right?
I mean, if you've ever felt completely overwhelmed by all the choices, you've got pip, conda, fenv, poetry, pipenv, the list goes on. You are definitely not alone. There's even a famous XKCD comic that nails this feeling perfectly. The community knows it's a complicated space. But here's the good news. Things have gotten so much simpler recently.
So let's just cut through all that noise. For modern, production-grade MLOps, the tool you really want to know about is Uv. It's just insanely fast. It's comprehensive. And it handles pretty much everything, managing your dependencies, your virtual environments, and even building your package. It basically simplifies the entire workflow into one sleek tool. Look, a lot of us, myself included, started out with Conda. And don't get me wrong, it's fantastic for research and exploration. But when you're talking about production systems, the industry standard is a bit different. We moved to this really powerful duo, UV to handle all the Python dependencies, and Docker to handle the underlying system. This combination, UV plus Docker, it's really the gold standard today. It gives you way better performance and truly isolated, completely reproducible environments. And the best part? Using UV is just refreshingly simple. To install your project's core libraries, you just run UV sync. That's it. Need to add your development and testing tools? Easy. You just run UV sync all groups. And when you're ready to build, it is one single command. UV build wheel. I mean, come on. Clean, simple, and super effective.
All right, so we've got our tool. Now let's actually look at the anatomy of the package itself. Let's break it down. A proper package really only has two main parts: a configuration file that defines the project and a specific folder structure for all your code. First up, let's talk about that configuration file. It's called pyproject.toml, and you need to think of this file as the absolute heart of your package. I love the analogy of it being your project's official ID card, or maybe even its passport. It holds all the vital information: its name, its version, and most importantly, exactly what other libraries it needs to function.
And trust me, looking inside this file is not scary at all.
You've got a name for your package, a version so you can track changes, and a short description. The really critical part is the dependencies section. That's just a list of the core libraries your code needs, like pandas or scikit-learn. You can even get fancy and define optional groups for things like your development or testing tools. It's all laid out right there, super clear and organized.
Okay, that's part 1 of the anatomy. Now for part 2. We've got the config files sorted, but where do you actually put your Python code? You know, your data processing scripts, your model training logic. Where does all that stuff live?
The answer is simple. And honestly, for any professional project, it's pretty much non-negotiable. You put it all inside a folder named SRC, which, as you probably guessed, stands for source. This is what's known as the source layout, and it is an absolutely critical best practice.
So why is this SRC layout so important? Well, there are 2 huge reasons. First, it prevents these incredibly frustrating bugs, you know the ones, where your code works perfectly locally, but then it breaks the second you install it somewhere else. This happens because Python gets confused about which files to import. The SRC layout forces Python to use the installed package, just like any other user would. And second, it just creates this beautiful, clean separation between your actual package code and all the project management stuff, like your pyproject.toml, your tests, and your docs.
Okay, we have defined our package, we've structured our code, now is time for the final payoff. Actually building this thing and sharing it with your team, or hey, maybe even with the whole world.
Remember that UV build command we talked about? Well, when you run that, it creates something called a wheel file. You'll see it has a .whl extension. So what is a wheel? It's basically a pre-built, pre-compiled version of your package. And here's why that's so great. When someone else installs your wheel, it's way faster and more reliable, because their computer doesn't have to waste time figuring out how to build your project from scratch. It's already done.
So you've got your shiny new wheel file. Now what? The decision really just comes down to your audience. If you've built an awesome open source tool that you want to share with the world, you're going to publish it to the public Python package index, which you probably know as PyPI. But if this is proprietary code for your company, you'll use a private registry, something like AWS Code Artifact or GCP Artifact Registry. That way, your code stays secure and is only accessible to your internal teams.
And once you've got your repository all configured, whether it's public or private, the final step is just beautiful in its simplicity. You just run one command, UV publish. And that's it. Your code is now officially a library, ready to be installed and used by anyone you've given access to. You have officially completed the journey from a simple script to a professional software asset.
And that really brings us full circle. You started with an idea, a model sitting in a notebook, and now you have the practical knowledge to structure it, to build it, and to distribute it as a professional, reproducible library. You've literally bridged that gap from research to production. So the only question left is, what incredible things are you going to build with this new power?